Section 3 of the Atomic Bombings of Hiroshima and Nagasaki. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, visit LibriVox.org. The Atomic Bombings of Hiroshima and Nagasaki by the Manhattan Engineer District, June 29, 1946. Section 3. General description of the damage caused by the atomic explosions. In considering the devastation in the two cities, it should be remembered that the cities' differences in shape and topography resulted in great differences in the damages. Hiroshima was all on low flat ground and was roughly circular in shape. Nagasaki was much cut up by hills and mountain spurs, with no regularity to its shape. In Hiroshima, almost everything up to about 1 mile from X was completely destroyed, except for a small number, about 50, of heavily reinforced concrete buildings, most of which were specially designed to withstand earthquake shock, which were not collapsed by the blast. Most of these buildings had their interiors completely gutted, and all windows, doors, sashes, and frames ripped out. In Nagasaki, nearly everything within 1/2 mile of the explosion was destroyed, including heavy structures. All Japanese homes were destroyed within 1 1/2 miles from X. Underground air raid shelters with earth cover roofs immediately below the explosion had their roofs caved in, but beyond 1/2 mile from X they suffered no damage. In Nagasaki, 1,500 feet from X, high-quality steel frame buildings were not completely collapsed, but the entire building suffered mass distortion, and all panels and roofs were blown in. In Nagasaki, 2,000 feet from X, reinforced concrete buildings with 10-inch walls and 6-inch floors were collapsed. Reinforced concrete buildings with 4-inch walls and roofs were standing but were badly damaged. At 2,000 feet, some 9-inch concrete walls were completely destroyed. In Nagasaki, 3,500 feet from X, church buildings with 18-inch brick walls were completely destroyed. 12-inch brick walls were severely cracked as far as 5,000 feet. In Hiroshima, 4,400 feet from X, multi-story brick buildings were completely demolished. In Nagasaki, similar buildings were destroyed to 5,300 feet. In Hiroshima, roof tiles were bubbled, melted, by the flash heat out to 4,000 feet from X. In Nagasaki, the same effect was observed to 6,500 feet. In Hiroshima, steel frame buildings were destroyed 4,200 feet from X and to 4,800 feet in Nagasaki. In both cities, the mass distortion of large steel buildings was observed out to 4,500 feet from X. In Nagasaki, reinforced concrete smokestacks with 8-inch walls, specially designed to withstand earthquake shocks, were overturned up to 4,000 feet from X. In Hiroshima, steel frame buildings suffered severe structural damage up to 5,700 feet from X, and in Nagasaki the same damage was sustained as far as 6,000 feet. In Nagasaki, 9-inch brick walls were heavily cracked to 5,000 feet, were moderately cracked to 6,000 feet, and slightly cracked to 8,000 feet. In both cities, light concrete buildings collapsed out to 4,700 feet. In Hiroshima, multi-story brick buildings suffered structural damage up to 6,600 feet, and in Nagasaki up to 6,500 feet from X. In both cities, overhead electric installations were destroyed up to 5,500 feet, and trolley cars were destroyed up to 5,500 feet and damaged to 10,500 feet. Flash ignition of dry, combustible material was observed as far as 6,400 feet from X in Hiroshima, and in Nagasaki as far as 10,000 feet from X. Severe damage to gas holders occurred out to 6,500 feet in both cities. All Japanese homes were seriously damaged up to 6,500 feet in Hiroshima and to 8,000 feet in Nagasaki. Most Japanese homes were damaged up to 8,000 feet in Hiroshima and 10,500 feet in Nagasaki. The hillsides in Nagasaki were scorched by the flash radiation of heat as far as 8,000 feet from X. This scorching gave the hillsides the appearance of premature autumn. In Nagasaki, very heavy plaster damage was observed in many buildings up to 9,000 feet. Moderate damage was sustained as far as 12,000 feet, and light damage up to 15,000 feet. The flash charring of wooden telephone poles was observed up to 9,500 feet from X in Hiroshima, and to 11,000 feet in Nagasaki. Some reports indicate flash burns as far as 13,000 feet from X in both places. Severe displacement of roof tiles was observed up to 8,000 feet in Hiroshima and to 10,000 feet in Nagasaki. In Nagasaki, very heavy damage to window frames and doors was observed up to 8,000 feet, and light damage up to 10,000 feet. Roofs and wall coverings on steel frame buildings were destroyed out to 11,000 feet. Although the sources of many fires were difficult to trace accurately, it is believed that fires were started by primary heat radiation as far as 15,000 feet from X. Roof damage extended as far as 16,000 feet from X in Hiroshima and in Nagasaki. The actual collapse of buildings was observed at the extreme range of 23,000 feet from X in Nagasaki. Although complete window damage was observed only up to 12,000 feet from X, some window damage occurred in Nagasaki up to 40,000 feet, and actual breakage of glass occurred up to 60,000 feet. Fire damage was sustained in a circular area in Hiroshima with a mean radius of about 6,000 feet and a maximum radius of about 11,000 feet. Similar heavy damage occurred in Nagasaki south of X up to 10,000 feet, where it was stopped on a river course. In Hiroshima, over 60,000 of 90,000 buildings were destroyed or severely damaged by the atomic bomb. This figure represents over 67% of the city's structures. In Nagasaki, 14,000 or 27% of 52,000 residences were completely destroyed, and 5,400 or 10% were half destroyed. Only 12% remain undamaged. This destruction was limited by the layout of the city. The following is a summary of the damage to buildings in Nagasaki as determined from a ground survey made by the Japanese. Destruction of buildings and houses. Number, percentage. compiled by Nagasaki Municipality. Total in Nagasaki, before atomic explosion, 50,000, or 100%. Blasted, not burned, 2,652, or 5.3%. Blasted and burned, 11,494, 23%. Blasted and or burned, 14,146, 28.3%. Partially burned or blasted, 5,441, 10.9%. Total buildings and houses destroyed, 19,587, 39.2%. Undamaged, 30,413, 60.8%. In Hiroshima, all utilities and transportation services were disrupted for varying lengths of time. In general, however, services were restored about as rapidly as they could be used by the depleted population. Through railroad service was in order in Hiroshima on 8 August, and electric power was available in most of the surviving parts on 7 August, the day after the bombing. The reservoir of the city was not damaged, being nearly 2 miles from X. However, 70,000 breaks in water pipes in buildings and dwellings were caused by the blast and fire effects. Rolling transportation suffered extensive damage. The damage to railroad tracks and roads was comparatively small, however. The electric power transmission and distribution systems were badly wrecked. The telephone system was approximately 80% damaged, and no service was restored until 15 August. Despite the customary Japanese lack of attention to sanitation measures, no major epidemic broke out in the bombed cities. Although the conditions following the bombings makes this fact seem surprising, the experience of other bombed cities in both Germany and Japan show Hiroshima and Nagasaki not to be isolated cases. The atomic explosion over Nagasaki affected an overall area of approximately 42.9 square miles, of which about 8.5 square miles were water and only about 9.8 square miles were built up, the remainder being partially settled. Approximately 36% of the built-up areas were seriously damaged. The area most severely damaged had an average radius of about 1 mile and covered about 2.9 square miles, of which 2.4 were built up. In Nagasaki, buildings with structural steel frames, principally the Mitsubishi plant, as far as 6,000 feet from X, were severely damaged. These buildings were typical of wartime mill construction in America and Great Britain, except that some of the frames were somewhat less substantial. The damage consisted of windows broken out, 100%, steel sashes ripped out or bent, corrugated metal or corrugated asbestos roofs and sidings ripped off, roofs bent or destroyed, roof trusses collapsed, columns bent and cracked, and concrete foundations for columns rotated. Damage to buildings with structural steel frames was more severe where the buildings received the effect of the blast on their sides than where the blast hit the ends of the buildings, because the buildings had more stiffness, resistance to negative movement at the top of columns, in a longitudinal direction. Many of the lightly constructed steel frame buildings collapsed completely, while some of the heavily constructed, to carry the weight of heavy cranes and loads, were stripped of roof and sidings, but the frames were only partially injured. The next most seriously damaged area in Nagasaki lies outside the 2.9 square miles just described, and embraces approximately 4.2 square miles, of which 29% was built up. The damage from blast and fire was moderate here, but in some sections, portions of main business districts, many secondary fires started and spread rapidly, resulting in about as much overall destruction as in areas much closer to X. An area of partial damage by blast and fire lies just outside the one just described and comprises approximately 35.8 square miles. Of this area, roughly 1/6 was built up and 1/4 was water. The extent of damage varied from severe damage to roofs and windows in the main business section of Nagasaki, 2.5 miles from X, to minor, broken or occasionally broken windows at a distance of 7 miles southeast of X. As intended, the bomb was exploded at an almost ideal location over Nagasaki to do the maximum damage to industry, including the Mitsubishi Steel and Arm Works, the Mitsubishi Urakami Ordnance Works, Torpedo Works, and numerous factories, factory training schools, and other industrial establishments, with a minimum destruction of dwellings and consequently a minimum amount of casualties. Had the bomb been dropped farther south, the Mitsubishi Urakami Ordnance Works would not have been so severely damaged, but the main business and residential districts of Nagasaki would have sustained much greater damage casualties. Calculations show that the structural steel and reinforced concrete frames which survived the blast fairly close to X could not have withstood the estimated peak pressures developed against the total areas presented by the sides and roof of the buildings. The survival of these frames is explained by the fact that they were not actually required to withstand the peak pressure because the windows were quickly knocked out and roof and siding stripped off, thereby reducing total area and relieving the pressure. While this saved the building frame, it permitted severe damage to building interior and contents, and injuries to the building occupants. Buildings without large panel openings through which the pressure could dissipate were completely crushed, even when their frames were as strong as those which survived. The damage sustained by reinforced concrete buildings depended both on the proximity to X and the type and strength of the reinforced concrete construction. Some of the buildings with reinforced concrete frames also had reinforced concrete walls, ceilings, and partitions, while others had brick or concrete tile walls covered either with plaster or ornamental stone, with partitions of metal, glass, and plaster. With the exception of the Nagasaki Medical School and Hospital Group, which was designed to withstand earthquakes and was therefore of heavier construction than most American structures, most of the reinforced concrete structures could be classified only as fair, with concrete of low strength and density, with many of the columns, beams, and slabs under-designed and improperly reinforced. These facts account for some of the structural failures which occurred. In general, the atomic bomb explosion damaged all windows and ripped out, bent, or twisted most of the steel window or door sashes, ripped doors from hinges, damaged all suspended wood, metal, and plaster ceilings. The blast concussion also caused great damage to equipment by tumbling and battering. Fires, generally of secondary origin, consumed practically all combustible material, caused plaster to crack off, burned all wooden trim, stair covering, wooden frames of wooden suspended ceilings, beds, mattresses, and mats, and fused glass, ruined all equipment not already destroyed by the blast, ruined all electrical wiring, plumbing, and caused spalling of concrete columns and beams in many of the rooms. Almost without exception, masonry buildings of either brick or stone within the effective limits of the blast were severely damaged, so that most of them were flattened or reduced to rubble. The wreckage of a church, approximately 1,800 feet east of X in Nagasaki, was one of the few masonry buildings still recognizable, and only portions of the walls of this structure were left standing. These walls were extremely thick, about 2 feet. The two domes of the church had reinforced concrete frames, and although they were toppled, they held together as units. Practically every wooden building or building with timber frame within 2.0 miles of X was either completely destroyed or very seriously damaged, and significant damage in Nagasaki resulted as far as 3 miles from X. Nearly all such buildings collapsed, and a very large number were consumed by fire. A reference to the various photographs depicting damage shows that, although most of the buildings within the effective limits of the blast were totally destroyed or severely damaged, a large number of chimneys, even close to X, were left standing, apparently uninjured by the concussion. One explanation is that concrete chimneys are approximately cylindrical in shape and consequently offer much less wind resistance than flat surfaces, such as buildings. Another explanation is that since the cities were subject to typhoons, the more modern chimneys were probably designed to withstand winds of high velocity. It is also probable that most of the recently constructed chimneys, as well as the more modern buildings, were constructed to withstand the acceleration of rather severe earthquakes. Since the bombs were exploded high in the air, chimneys relatively close to X were subjected to more of a downward than a lateral pressure, and consequently the overturning moment was much less than might have been anticipated. Although the blast damaged many bridges to some extent, bridge damage was on the whole slight in comparison to that suffered by buildings. The damage varied from only damaged railings to complete destruction of the superstructure. Some of the bridges were wrecked and the spans were shoved off their piers and into the riverbed below by the force of the blast. Others, particularly steel plate girder bridges, were badly buckled by the blast pressure. None of the failures observed could be attributed to inadequate design or structural weaknesses. The roads and railroad and street railway trackage sustained practically no primary damage as a result of the explosion. Most of the damage to railroads occurred from secondary causes, such as fires and damage to bridges or other structures. Rolling stock, as well as automobiles, trolleys, and buses, were destroyed and burned up to a considerable distance from X. Streets were impassable for a while because of the debris, but they were not damaged. The height of the bomb explosion probably explains the absence of direct damage to railroads and roads. A large part of the electric supply was interrupted by the bomb blast, chiefly through damage to electric substations and overhead transmission systems. Both gas works in Nagasaki were severely damaged by the bomb. These works would have required 6 to 7 months to get into operation. In addition to the damage sustained by the electrical and gas systems, severe damage to the water supply system was reported by the Japanese government. The chief damage was a number of breaks in the large water mains and in almost all of the distributing pipes in the areas which were affected by the blast. Nagasaki was still suffering from a water shortage inside the city 6 weeks after the atomic attack. The Nagasaki prefectural report describes vividly the effects of the bomb on the city and its inhabitants. Quote, "Within a radius of 1 kilometer from X, men and animals died almost instantaneously, and outside a radius of 1 kilometer and within a radius of 2 kilometers from X, some men and animals died instantly from the great blast and heat, but the great majority were seriously or superficially injured. Houses and other structures were completely destroyed while fires broke out everywhere. Trees were uprooted and withered by the heat. Outside a radius of 2 kilometers and within a radius of 4 kilometers from X, men and animals suffered various degrees of injury from window glass and other fragments scattered about by the blast, and many were burned by the intense heat. Dwellings and other structures were half damaged by blast. Outside a radius of 4 kilometers and within a radius of 8 kilometers, living creatures were injured by materials blown about by the blast. The majority were only superficially wounded. Houses were only half or partially damaged." Close quote. The British mission to Japan interpreted their observations of the destruction of buildings to apply to similar construction of their own as follows. A similar bomb exploding in a similar fashion would produce the following effects on normal British houses. Up to 1,000 yards from X, it would cause complete damage. Up to 1 mile from X, it would damage the houses beyond repair. Up to 1.5 miles from X, it would render them uninhabitable without extensive repair, particularly to roof timbers. Up to 2.5 miles from X, it would render them uninhabitable until first aid repairs had been carried out. The fire damage in both cities was tremendous, but was more complete in Hiroshima than in Nagasaki. The effect of the fires was to change profoundly the appearance of the city and to leave the central part bare, except for some reinforced concrete and steel frames and objects such as safes, chimney stacks, and pieces of twisted sheet metal. The fire damage resulted more from the properties of the cities themselves than from those of the bombs. The conflagration in Hiroshima caused high winds to spring up as air was drawn in toward the center of the burning area, creating a fire storm. The wind velocity in the city had been less than 5 miles per hour before the bombing, but the fire wind attained a velocity of 30 to 40 miles per hour. These great winds restricted the perimeter of the fire, but greatly added to the damage of the conflagration within the perimeter and caused the deaths of many persons who might otherwise have escaped. In Nagasaki, very severe damage was caused by fires, but no extensive fire storm engulfed the city. In both cities, some of the fires close to X were no doubt started by the ignition of highly combustible materials such as paper, straw, and dry cloth upon the instantaneous radiation of heat from the nuclear explosion. The presence of large amounts of unburnt combustible materials near X, however, indicated that even though the heat of the blast was very intense, its duration was insufficient to raise the temperature of many materials to the kindling point, except in cases where conditions were ideal. The majority of the fires were of secondary origin, starting from the usual electrical short circuits, broken gas lines, overturned stoves, open fires, charcoal braziers, lamps, etc., following collapse or serious damage from the direct blast. Firefighting and rescue units were stripped of men and equipment. Almost 30 hours elapsed before any rescue parties were observable. In Hiroshima, only a handful of fire engines were available for fighting the ensuing fires, and none of these were of first-class type. In any instance, however, it is not likely that any firefighting equipment or personnel or organization could have effected any significant reduction in the amount of damage caused by the tremendous conflagration. A study of numerous aerial photographs made prior to the atomic bombings indicates that between 10 June and 9 August 1945, the Japanese constructed fire breaks in certain areas of the cities in order to control large-scale fires. In general, these fire breaks were not effective because fires were started at so many locations simultaneously. They appear, however, to have helped prevent fires from spreading farther east into the main business and residential section of Nagasaki. End of Section 3 of the Atomic Bombings of Hiroshima and Nagasaki.